The reversible process. The question that can now logically be posed in this: if it is impossible to have a heat engine of 100 efficiency, if it is impossible to have a heat engine of 100 efficiency, what is the maximum efficiency one can have? What is the maximum efficiency one can have? The first step in the answer to this question is to define an ideal process. Or reversible process. A reversible process for a system is defined as process that is defined as a process that once having taken place can be reversed and in so doing leave no change in either system or surrounding. Let us illustrate the significance of this definition for a gas contained in a cylinder that is fitted with a piston. Consider this picture. Consider this picture, which is a gas which we define as the system is restrained at high pressure by a piston that is secured by a pin. When the pin is removed, the piston is raised and forced abruptly against the stop. Some work is done by the system, since the piston has been raised a certain amount. Suppose we wish to restore the system to the initial state, the initial process shown here. The pin was detached from the system and the piston expanded and some work was done. Suppose we wish to restore and thus compress the gas until the pin can be inserted in the piston as this picture. Since the pressure of the face of the piston is greater on the return stroke than on the initial stroke, the work done on the gas in this reverse process is greater than the work done by the gas in the initial process. The work done in reverse greater than the work in initial process. An amount of heat must be transferred from the gas during the reverse stroke so that the system has the same internal energy as it had originally. We talk about this Q. Thus, the system is restored to its initial state, but the surroundings have changed by virtue of the fact that work was required to force the piston down and heat was transferred to the surrounding. The initial process, therefore, is an irreversible one because it could not be reversed without leaving a change in the surrounding. So in this case we have Q to the surrounding. So there is a change. So it is irreversible. Irreversible. Because it could not be reversed without leaving a change in the surrounding, so is Q. It is an irreversible process, and now consider this picture for more description. This picture also is a sample for the description. In this figure, let the gas in the cylinder comprise the system, and let the piston be loaded with a number of weights. Let the weight be slid off horizontally and at a time, allowing the gas to expand and do work in raising the weight that remains on the piston. Do work with mass revolving. As the size of weight is made smaller and the number is increased, we approach a process that can be reversed. For at each level of the piston during the reverse process, there will be a small weight that is exactly at the level of the platform and thus can be placed on the platform without requiring the work. In the limit, therefore, as the weight becomes very small, the reverse process can be accomplished in such a as the weight are very small. Then we add mass. Again, we can have the reverse process. Such a process is because there is no change in the surrounding and the system. Removing and add mass to to their system do not or don't have effect on solving. Effect on solving and systems. In the limit, therefore, as we become very small, we have this position. So it is a reversible process.